MS Ramaya University of Applied Sciences.
Clotting time writes capillary glass tube method. Aim of the experiment: to determine the clotting time of blood sample and to assess the problems related to clotting mechanism. Introduction. Bleeding after injury is a common experience for most of us, but bleeding stops automatically within a few minutes. However, suspicion of a disease arises when there is a frequent and prolonged bleeding with minor injuries such as shaving, cutting of nails, or a fall on the knees. Hemostasis. The term hemostasis refers to the process of stoppage of bleeding after blood vessels are punctured, cut, or otherwise damaged. Hemostasis, which is a hemostatic mechanism to prevent loss of the blood, is a result of complex natural physiological responses. Hemostasis involves the following four interrelated steps. Number 1, vasoconstriction. Number 2, platelet plug formation. Number 3, formation of a blood clot. And number 4, fibrinolysis. Clotting is a natural defense mechanism to prevent blood loss from the body. It is initiated by two pathways, that is intrinsic and extrinsic pathway. The clotting of blood with this mechanism or method involves both the intrinsic and extrinsic system of clotting. There is injury to the blood which is coming into contact with the glass, which leads to intrinsic pathway, and the injury to the tissues, which is extrinsic pathway. Clotting time. It is the time interval between the entry of the blood into the glass capillary tube and formation of fibrin threads. The clotting time is prolonged in hemophilia and other clotting disorders because thrombin cannot normally be generated. Experimental setup: glass capillary tube 10 to 12 centimeter in length and 1 to 2 millimeter in diameter, blood lancet, stopwatch, 70% alcohol and cotton swab. Experimental procedure: get a sterile finger prick to get free flowing blood, dip one end of the capillary tube in the blood. The blood rises into the capillary tube by capillary action. Note the time when blood starts to enter the tube as 0. Hold the capillary tube between the palms of your hands to maintain the blood near body temperature. Gently break off 0.5 to 1 centimeter bits of glass tube from one end at intervals of 30 seconds and look for the formation of fibrin threads between the broken ends. The end point is reached when the fibrin threads span a gap of 5 mm between the broken ends, which is called as rope formation. Note the time. Precautions: if bleeding continues for more than 10 minutes, stop the test and press sterile gauze on the prick. Inform the concerned about bleeding.
Hi students, today we are going to study clotting time. The aim of this experiment is to determine the clotting time and to assess the problems related to the clotting mechanisms. Clotting time is the time interval between the entry of the blood in the capillary tube and formation of the fibrin threads. The purpose of this experiment is to aid in the diagnosing of various clotting disorders or coagulopathies such as thrombocytopenia, vascular defects or vascular abnormalities, platelet defects, and von Willebrand's disease. Now, let us see and understand various requirements of this experiment. Lancet, blood lancet, which consists of a sharp needle to prick the finger bulb. Lancet device. This is utilized to hold the lancet. The depth of the prick or the length of the needle can be adjusted by a calibrated knob which is provided in the top. Cotton swab with alcohol to sterilize the finger bulb. Dry cotton swab to remove the excess of alcohol. Capillary tube. Glass capillary tube which is 8 to 10 centimeter in length and 1 to 2 millimeter in diameter. Stopwatch and a stopwatch to measure the time. Now let us start the clotting time experiment. Sterilize the finger bulb with cotton swab with alcohol. The finger bulb should be properly cleaned with the 70% alcohol on both the sides and allow the alcohol to vaporize. Once the alcohol vaporizes, using the lancet device, prick the finger bulb and squeeze the finger bulb gently to the formation of the blood drop. Once the blood drop is formed, touch the tip of the capillary tube to the tip of the blood droplet and allow the blood to fill the capillary tube. Due to the capillary action, the blood will automatically start raising in the capillary tube. And once the capillary tube is completely filled with the blood, switch on the timer. Then for every 30 seconds, start breaking off 0.5 centimeter of the capillary tube. Once the capillary tube is filled, switch on the timer and keep the capillary tube horizontally in your palm so as to maintain the body temperature. Then for every 30 seconds, start breaking 0.5 centimeter of the capillary tube and check for the appearance of fibrin clot. The end point of this experiment is when the fibrin clot appears. There is no appearance of fibrin clot at 30 seconds. No clot at 60 seconds. Now at 2 minutes 30 seconds, no clot. At 3 minutes you can see a thin thread like structure which is getting formed, which is nothing but fibrin clot. The clotting time of the given blood sample was found to be 3 minutes. This completes the study of clotting time.
At MSR UAS, we spark your imagination unlike any other.